Let's kick off. Great to see you all. Good morning, everybody. Day 2 at DevWorld. I mean, what an amazing place, right? A lot of talks, a lot of information, a lot of great people, which makes a lot of fun, right? Thanks, everybody, for joining this talk. First, before I start, who already has experience with building GenAI applications? Can I get a quick show of hands? All right, that's about half. How many people already are aware of large language models and vector search technologies? Oh, that's about everybody, I think, right? Something like that. Great. Because that's what we'll be talking about today. We'll be talking about vector search and what vector search can do for your company. The problem with everything around generative AI, vector search, large language models, is that it's still in a very brittle state. There are so many tools out there. There is so much open source. And there is so much development and innovation going on continuously that you'll easily run into a situation where your applications will break because dependencies are failing, because you're not getting back from an API what you're expecting. Is that something that you're familiar with? Yeah, here, yes, big yes. So other people, yeah, there you go, right? So that's what we'll be talking about today. How can you actually take a step from prototyping and go into production with GenAI? Because that's essentially what we're after, right? I mean, it's a lot of fun, right? It's a lot of fun prototyping and getting these LLMs model and seeing the magic happen just right in front of your eyes. But the goal, of course, is and has to be going into production with these kind of technologies. So that's what we'll be talking about today. Let's start by talking about why GenAI is hard. I'm sure you're sick of seeing these kind of architecture diagrams, right? Everybody's seen them, agents, large language models, retrieval from a database, a vector database, of course, getting the data back, summarization, send it to an LLM, and get your response back. Pretty simple, but the reality is difficult. So Physics Wallet is one of our customers. They actually went live with generative AI and our technology, which is an amazing vector database. We'll talk more about that. They went live with that for about 150,000 people. That's about 10% of their audience. This is a company in India. They're selling books for universities. And they suddenly saw changes in behavior. But what caused it, right? When we're thinking about GenAI, we're thinking about long chains of technologies that have to work together. And it's sometimes not so easy to find out where something goes wrong. Also, we're working with a large Dutch bank here in the Netherlands. Well, actually, we're working with all of the large Dutch banks in the Netherlands. But, the problem that they're facing is they're in a regulated vertical. And that means that they need supported software, right? It's not that they wouldn't like to use just open source and unsupported stuff. The regulator demands that they're using supported technologies where they can get support 24/7, 365. How do you get that in a brittle chain of large language models, GenAI, vector search, LangChain, LLamaIndex, and everything else? It's pretty difficult. And then also due to regulations, it's very difficult for them to share sensitive data from customers like P2I data, personally identifiable information, outside of their firewalls, right? So it's a regulatory problem that you're running into. So it prevents them from making you know, amazing steps with this magic technology. What we're seeing is that these GenAI apps, they often break, you know, and it's because of lots and lots of dependencies. Who's been playing around with Python and large language models? Yeah. So on average, how many dependencies do you have to install? And how many dependencies are being installed by these dependencies? There you go, right? It's tons and tons and tons of dependencies. And they're all dependent on specific versions, right? Then we're making calls out to external APIs. Maybe the OpenAI API, Cohere API, Anthropic API, right? Whatever API. There are so many APIs. And they're all in development. They're all changing. And by the way, they also have their own release schedule, right? So if you just found something that integrates with each other, they will independently of each other, they will start changing the APIs and things break again. So essentially it means that enterprises need a proven path to success, because else they won't be able to put their GenAI applications into production. And that's not depending on unsupported open source frameworks. You know, how beautiful all these frameworks are and how fast it helps us to create applications, you know, especially in a Collab notebook, right? Spin up a Collab notebook, import some packages, and, you know, you're done in 10 minutes and you have a most beautiful RAG application. Great. But it's all unsupported open source projects. And these projects often come from small vendors. And a small vendor, for instance, is LangChain, right? I mean, let's face it, LangChain is who's aware of LangChain? Okay, that's a lot of people. You know, they're doing amazing work. They're doing amazing work, just like LLamaIndex, right? We're speaking with Harrison Chase, the CEO of LangChain, really often. The struggle that they have is they're like a 25 people company. How are they going to support, you know, an ING over there or an ABN AMRO over there? It's impossible. It's even difficult for them to engage with these kind of enterprises and organizations because they don't have the organization set up to be able to really engage with them, right? Organizations like that will crush them because there is too many dependencies within the organization to deal with. And that's why often these small vendors won't even want to cooperate with these kind of enterprises, right? So there's a gap. There's a gap. And that's the gap that we'll be talking about in terms of production GenAI. So what do you need? There are some key components, right, that we're seeing across the stack. There's some key components that we see evolving. You know, we see a lot of LangChain and LLamaIndex for orchestration, and that's for a good reason. You know, these packages, they essentially contain everything that you need to get started. You know, first of all, it starts with content, right? I come from the publishing industry, so I feel like kind of a dinosaur by now. But back in the day, the phrase that we always used was, content is king. And although content still is important, I would say nowadays, context is king, right? Because it's all about providing context in real time to a large language model that can use that information, first of all, to create magical responses, but secondly, also prevent hallucinations. Because if you are able to provide contextual information to a large language model, then there is no need or reason for an LLM to start hallucinating anymore, right? And that's where these frameworks are really good at. They're really good at getting your content, your IP, the thing that makes a difference in the world of GenAI. They make it really easy to get that information into a vector database so that you can search for the most relevant information and then apply it to the large language model, you know? And there is a lot of magic going on behind the scenes there, because you need to think about chunking strategies, right? Who's aware of chunking? What does it mean? Yes, let's say 30% of people. Yeah, let's put it like this. If you have a 250-page PDF and you have a vector representation, which essentially has to capture the true semantic meaning of that PDF document, and your vector representation exists of about 1,500 dimensions. You can understand that with 1,500 dimensions, although it's a lot, you cannot capture the true semantic meaning of the whole PDF. And that's why you have to chunk it into small pieces, so that those small pieces, the semantic knowledge of those small pieces, actually fits into a vector representation that makes sense for a vector database, and that allows you to run queries that actually get meaningful information back, right? So that's chunking. And that's something that these components offer. Some other key components that we're seeing evolving is something like streaming for data pipelines. You know, getting data into your application and making sure that your data stays up to date in real time is something that's really, really hard, right? You don't want to be dependent of a Python process. You don't. First of all, it's not scalable. Second of all, it can break really easily, right? So you want to use a streaming technology, because streaming technologies are built for this, right? So this is another part that's really crucial in the world of generative AI. And I feel a bit sorry for everybody, essentially, because, you know, we're all playing around with this GenAI stuff, and we're all creating magic. But then we need to start thinking about how do we do this in production, and then all the topics, right? All the topics of the past, they're coming on the table again, right? We have to start thinking about how we can create robust applications. So what we really want to do is we want to implement state-of-the-art RAG technologies that are proven to work in production. And then another thing that we want to do is we want to aggressively test the large language models so that we're sure that they are meeting enterprise requirements. And that's not getting one response today and another response tomorrow. Because again, if you're in a regulated vertical, or if you're dealing with people and people's information, you have to be sure about the information that you're providing, right? And that's kind of difficult with a non-deterministic technology. So this is where DataStax, company I work for, vector search company, database, what we decided to do is provide a framework that allows you to run all of this great stuff in production. And this framework is called RAGStack. RAGStack essentially is a software stack of de facto solutions that people need for GenAI. And that means that we're not building anything ourselves. Well, we will, but you know, we are basing ourselves on the latest and greatest technologies out there. That means that RAGStack contains a curated version of LangChain. RAGStack contains a curated version of LLamaIndex. And, you know, I was just talking about these 25 people companies. They actually love working with us because they see themselves as the fedora of the Linuxes in the world of LLMs. And we're providing the Red Hats, the Red Hat of the Linuxes in the world of GenAI. You know, and that's something that these companies just cannot do, right? They're really good at innovating, and they're really good at creating amazing applications. But for them, it's really difficult to provide something that is actually production ready, and also difficult to create to add support to that. You know, the other component of RAGStack is we have a test framework, and I will show it to you later on as well, that security tests, pen tests, and compliance tests all these frameworks. And that's pretty important, right? Because I was just looking at the test framework that you can all, by the way, look at as well. It's available on the internet. And the latest version of LangChain has problems with SQL injection. You don't want that in a production environment, right? So it's pretty important to keep track of these kind of things. And we're running these tests for all of you, essentially, right? If you want to use something like RAGStack in production, we're running all of these tests every few hours. So yeah, that's, by the way, this is a quote of the CEO of SkyPoint. SkyPoint is a cloud provider that offers a lot of AI functionalities. And they've just decided to use RAGStack, right? Because they don't want to be bothered with the complexity of maintaining open source components that have a lot of dependencies. So like I said, what does it package? It's a curated set of software components containing LangChain and LLamaIndex. And the beauty of it, it means that you don't have to change anything in your code. If you're currently using LLamaIndex or LangChain, you don't have to change your code, not one sentence in it. The only thing, in this case, that you have to do is, out of your requirements.txt, or however you install, pip install all your components, you can throw them all away. The only thing is you can replace them with RAGStack-AI, and you're done, right? And that's the value of something like RAGStack. It also works well with AstraDB. Who's heard of AstraDB? Okay, a few people. That's great. That's great. There's some work for us still to do, Dot. But anyways, AstraDB is a database that's built on the best that Apache Cassandra has to offer, right? Apache Cassandra, well-tested, proven database for already 12 years in the market, with a lot of innovations going on. One of the innovations, for instance, is the addition of ACID transactions, which is pretty cool, right, for a distributed database. Based on a paper that Apple wrote. It's based on the Accord protocol, which is the single fastest transactional protocol for distributed databases in the world, period. So that's pretty interesting. What we have committed to, because DataStax is one of the main committers behind Apache Cassandra, commit about 70% of the source code. One of the things that we've contributed to it is vector search functionality. Because let me tell you one thing, vector search is a feature. Vector search on itself is not a database, right? And what we've been seeing in the market is that a lot of vendors have been creating vector search functionality and then trying to create a database around it. Well, creating a database is one of the hardest things you can do, right? So that's why we thought, hey, we already have Apache Cassandra, which is used by 90% of the Fortune 100, which has already proven itself in the market. Why not add vector search to that? And on top of that, we implemented a new way of doing vector search. So a lot of vector search technologies are based on Elastic's HNSW. Rings a bell? HNSW? It's nice. Well, it's not the most elegant implementation. So we created a new implementation that's based on disk ANN. It's open sourced as well. If you want to have a look at JVector. That's the name for the new vector search algorithm. And it's 74% faster than the fastest vector database on the planet currently. On top of that, it's also, when you query it, it's 20%, it provides you with 20% more relevant results as well, right? And that's because if you have a lot of vectors in your vector space, it becomes difficult to extract the right vectors out of that. You know, because you have to navigate that whole world of vector information. So AstroDB provides you with 20% better relevancy upon querying the database, which is a lot. So I'm pretty safe to say that currently AstroDB is the best vector database in the world, and I'm pretty proud of it. So this is the test harness. You can look it up. It's on ragstack-ai.testspace.com. Right? You can click through it. All of the tests are there. You know, if something fails, like yesterday, I just saw that there was this SQL injection issue. You know, it will flag red, and it's pretty important to know that. Here's a quote from Harrison Chase. Like I said, we work a lot together. And what he essentially says is that we've recognized the pain point in the market, and we're working to remedy that together, right? So this is a really great partnership. Again, I'm pretty proud of it, right? Because this is like the most sexy technology currently out there. So everybody wins. You know, developers in the area of Python using LangChain, LLamaIndex. And it means that they can also use their core competencies in terms of app development and don't have to worry about all these nasty production issues that you could run into. Other stakeholders, and this is important for enterprises, right? Not for the individual developer who wants to create a prototype, but this is important for enterprises, right? Security scans are done. There is confidence for compatibility, that things don't just break. There is long-term support, right? And I know that there are some people from large enterprises here in the audience. I won't point you out, but you know that long-term support is a really, really important thing, right? And you're not getting that from any of the GenAI functionalities out there currently. And as DataStax, right? We're a 600 people company. We're headquartered in the Valley. We have offices all over the world, and we have a follow the sun support system, right? So that means that we can actually offer 24/7, 365 enterprise support on your GenAI applications. And that means that it's a strategic alternative to building your own, forking from LangChain or LLamaIndex, and then risking technical debt. And it's also a strategic alternative to closed stacks, right? Because you could say, yeah, but I can use OpenAI. Well, sure you can, but do you really want to use OpenAI, right? Because the developments in the world of GenAI are so blazing fast, right? Every week there is something new. So I really think, you have to have a strategy where you can make sure that you're open to using anything that's out there. And that could mean that you're using OpenAI today, Gemini tomorrow, and Bedrock the day after, right? And the only way to do that is to make sure that the differentiator that you have is stored in a database that's worth storing your data in. Because I can tell you one thing, all of these bells and whistles in the GenAI functionalities out there, they are not going to be your differentiator. Because everybody has access to the LLMs. Everybody has access to embedding models, right? Everybody has access to multimodal stuff like Gemini or whatever. So that's not going to be your differentiator. The differentiator that you have, like I said, right, in my dinosaur time in publishing, it's your content. Because with your content, you can create the context that makes the difference. And that's a competitive, sustainable advantage right there. This is a webinar that we're going to host together with the CEO of Imprompt. They're using RAGStack in combination with LLamaIndex, because they also decided that they don't want to have the fuss of maintaining all these open source packages. So Yeah, you can have a look over there. So now, we're at the developer conference, right? Who would like to see some code? Yeah, there you go, right? Code. This is an application that we've created. It's kind of fun, right? Who's a Swiftie fan, by the way? No Swiftie fans? Come on! Really? Holy shit, okay. My bad, I took the wrong example. So what we did is we ingested a bunch of public information from Taylor and created a chatbot about that. And I think it's built on a lot of cool technologies, right? So Vercel is pretty nice, runs Next.js, you know, it's kind of the de facto standard. It's using Cohere and OpenAI just to show that you can use both of them, right? There's no need to put all of your eggs in one basket. And it's also using LangChain, and obviously it's using the best vector database in the world, which is AstraDB. By the way, if you scan the QR code, it brings you to the GitHub repository of the application, right? So it's all open, it's all available, and you can have a look there. This is how it works. We have the ingest side, which we're implementing with LangChain. Then we're creating embeddings. So the chunking is done by LangChain. Then we create the embeddings with an embedding API from Cohere. We're inserting that information in AstraDB, so the actual content plus the vector representation goes into AstraDB. And then we're using Vercel with Next.js to create a front-end application. And we're using a large language model from OpenAI to come back with the results, right? So a nice bunch of technologies working together. So ingesting the data, pretty simple. Right? We import AstraDB. Done. Vector database right there. We're using Puppeteer to load and retrieve information from URLs. Then we're using the recursive character text splitter from LangChain, which is pretty awesome. Cohere client is really simple to connect to. And that's about it. Then here, we're connecting to Cohere, we're connecting to AstraDB, which is, as you can see, pretty simple, because it's just the instantiation of a new AstraDB class. And then we're instantiating the recursive character splitter. Next up is creating a collection. So creating a collection in AstraDB is just a few lines of code, pretty simple. And by the way, in this in this application, we're using a pretty low density vector representation, right? So 384 dimensions, it's not a lot, but hey, I guess for the kind of content that you can assume that's available around Taylor Swift, I don't know, probably 384 is enough to capture the true semantic meaning, right? I don't know, but yeah, I guess so. Then we're scraping the page. Well, you know, I won't go into this too much because that's not so interesting. And then we're loading the sample data. We're chunking it up, as you can see. And then we're creating a vector representation out of that as well. I'll just go quickly around this because you can scan the QR code and, you know, have a look at the code itself. Now to the RAG part of it, right? So now we're switching to the right part of the diagram where we do the RAG framework. Again, you know, Cohere client, open because we're using some stuff on the Cohere side as well. OpenAI. We're using the Vercel AI framework, by the way, which is pretty interesting as well. And then, of course, AstraDB again. Here's some connections, pretty simple. We reach out to OpenAI with the OpenAI API key. We get the connection to AstraDB instantiated. And then we're starting to search for the right document. So this is essentially the contextual part in the retrieval augmented generation, which is done. And then once we have the context, we need to inject it in real time into the large language model so that the large language model does not see a need to hallucinate, right? This is, for me, this is the magic in all of it, right? This is the magic in retrieval augmented generation. Because if you're able to find semantically important information and you're able to inject it in real time, tell the large language model to use that and to not make up an answer, you're pretty well into going into a situation where there is no hallucination, right? So this is an example of the prompt that we're using. Then we call the chat completion, and essentially, right, we're done. Pretty simple, pretty easy, but pretty cool as well. Last part of this presentation, who wants to win a Sonos ROM? No, not everybody? Come on, who wants to win a Sonos ROM? Right, there you go. So we have a challenge for you. We have a challenge. It's super easy to win the Sonos ROM. Just scan the QR code, provide your name, email address, because we need to be able to contact you, and your login ID for AstraDB. Because I'm so pumped about the best vector search database in the world that I would love for all of you to have a look at it, right? Just try it out. On AstraDB, you get $25 for free every month. And then you may think, well, $25, what can I get out of it? Well, for instance, you get about 80 million queries out of it. Right? For just for $25, that's pretty amazing, right? So it's essentially it's your development database right there. Not only that, right? Like I said, AstraDB is really pretty amazing. It's really pretty amazing, cool stuff. Challenges are solved, right? Scaling problems, we scale automatically. It is based on the best of Apache Cassandra, but it's one of the very few true serverless databases in the world. So what we did is we took Apache Cassandra because we built it, we tore it apart in microservices, and all of these microservices we're orchestrating on Kubernetes. And that means that if you're write heavy, we just scale the writers. If you read heavy, we just scale the readers. If you have a lot of updates going on, we'll scale the compactor, you know? And that means that we will always use the least amount of resources needed, which is good for you because you're paying the least amount of money for it, right? On top of that, you know, vector search is just the best currently that you can get. There's some, and it's not just us saying, right? This is a report from an external company, GigaOM, they're researchers, and they actually researched and did a comparison of AstraDB versus Pinecone. Well, numbers speak for themselves, right? So, if you want to enroll into the raffle, just browse to db.new, which I think is one of the coolest URLs to create a new database, actually, right? So browse to db.new. I'll do it as well. And we'll all create a new account here, right here, right? So I'm going to db.new. Let's go. I have it on my screen. And on the bottom of the screen, it says don't have an account. Sign up. So click on sign up. And then you can either sign up through GitHub, through Google, or you can use your own username and password. That's it. Nothing more, nothing less. No credit card required, right? You will get $25 for free every month to play around with. And once you've done this, you did not only get the best vector database in the world, you also have a chance to enter the raffle, right? So once you're done with this, go back to the form, Let us know your name, email address, and your username on AstraDB. I will raffle off the Sonos Roam later today at our booth C13. Thanks, everybody. Thanks a lot. If you have any questions, please swing by on our booth C13. We have a bunch of people over there, and we're happy to answer all of your questions. And happy production GenAIing. Thank you.